Hi, Assalamualaikum warahmatullahi wabarakatuh. Um, Now, apart from representing a function using the idea of mapping, which you have seen in the previous video, well, this is mapping. Okay, you can also use different ways to represent any given function. So the first one that we're going to look at is ordered pairs, and this is something that you have seen in the previous video as well. So basically, this one is mapping, and you can change the representation of this into ordered pairs. So 2 to 6, you can write it down in terms of 2, 6, 5 and 15, and 10 and 30. So this is a representation in terms of ordered pairs. Okay, next you can also represent your function using a table as shown here. So this is x is the input and y is the output. So basically you're saying that 2 will be mapped to 11, 8 will be mapped to 35. Okay, and the next one is you can also represent a function using a graph. So this is an example of a function represented by by a graph. So this is a straight line, and if you want to change its representation to equation, you can. So you can also represent a function in terms of equation. So this is the equation of a function, which is a linear function. Y is equal to 3x plus 1. So altogether there are 5 ways to represent any given function: mapping, ordered pairs, table, graph, and equation. Alright, next we're going to look at some of the common terms that we should know when we talk about function. So those terms are, domain versus codomain, image and range, and these are explained as follows. So when you talk about a particular input, it is usually denoted by X. Okay, so this is a particular input here. So this is X. And of course, when you have a lot of other inputs, or the all possible inputs, if you consider all possible input, this is a particular input, one particular input. So if you have all possible input, for example, you have this could be x1, x2, x3, dot 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 xn. So these are all possible input, and it can be represented by set A. So this is set A, and this is also known as domain of a function, which is this one. So domain is actually the set of all possible input. Okay, next, now a particular output. So when you talk about a particular output, you're talking about one specific output, which is the value of a function at x. So for example here, if I have, this is x1, yeah, okay, I'm changing it to notation x1. So for example, this is x1 is being mapped on to this value, so I'm going to label this as x1 as well. So this particular input is being mapped to this particular output. So this is a particular output, yeah, this is a particular output. So it is known as the value of a function at x, and it is also known as the image of x. So this is the image of x. Image of, in this case, I'm using x1, so image of x1. So it can be mathematically represented as y, which in this case will be y1, or it can also be represented as fx1. Okay, so we have done with this definition and this one and this one. So now when you have all possible output, that could possibly come out of a function, which is represented by set B, then that is the definition of a codomain of a function. So the codomain of a function consists of all possible output. So for example, x2 here could be given as fx2, and you also have fx3, and dot 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 dot, you may have fxn. So this is all codomain. Okay, the definition of codomain. Okay, next, range or image. Well, you have seen the idea of image just now. So range is the set of all actual values produced by the function. So range is given as a subset of codomain here, because you can see that the range is in this circle. So range is a subset of a codomain, and it is the set of all actual values produced by the function. Okay, now is there really any difference between codomain and range? Well, usually the codomain is sometimes that is explicitly defined as part of the function. Okay, it is usually defined in advance, whereas the range here is the set of actual values that actually obtained. Okay, so for example, we can consider this function. So this function here is a function f of x. Okay, so this is equal to 2x. So this is a function where domain and codomain considered here are all possible integers. So this is something that are defined in advance. The domain and codomain are all possible integers. Now, when you look at it, what do you think are the possible values of x? So possible values of x, and what do you think are the possible values for fx? Now, since x here can be all possible integers, it can be -1, it can be 2, it can be 3, it can be -10, it can be -11, it can be anything as long as they are integers. You can see that when you have these values of x and you multiply with 2, you will get possible values of fx are going to be even integers. So it is more specific than possible integers. You can see that this is codomain, where codomain here is talking about integers, but the range here is getting more narrowed, and you are just focusing of even integers. Okay, so that's the idea of codomain and range. So the range here is a subset of a codomain. Now, based on the diagram below, determine the domain, codomain, and range. And so for this one, the domain here is just A, B, and C. This is the domain. All possible inputs. Okay, all possible inputs. Next, the codomain is all possible outputs, which is E, F, G, H, I. And finally, the range is just the actual values that you get, which is F, G, and H. Okay. Alright, I think that's all for now. Thank you very much for watching.